అంతే. Good morning. Welcome to SAKALAVIDYA YouTube channel. So, due to my ill health conditions, actually I didn't continue for 2 days. Okay, today we shall have 1 hour session. That's only today, because still I need to recover. By 9:30 we shall start the class. Still we have 8 minutes time. Still our regular viewers need to join now. Okay, fine. Okay, it's good now. Okay. So not yet started class. So in the last class, actually combinations we have completed up to 62 problems. I think so. Am I correct now? Okay, now it's okay. Because I know you are eagerly waiting for my classes. So that's why at least 1 hour I shall take the class today. Evening session, if so good, then I will continue the classes evening also. Okay? But you will understand. Okay, most of the models have been covered in combination. Just only few models that today only we will conclude the combination sessions. Okay? Right. And moreover, and 26th 10 to 10:45, only 45 minutes we have Zoom meeting session, interaction with parents and your children. So regarding to the our classes, already we have been actually conducting the classes for 4 months. And during 4 months actually you attended my classes, so you need to share your views and your any queries and doubts that can be had on that day. So because definitely you need to attend. So far we have received 76 responses from you, so that we will definitely forward emails to you, all of you, for password and ID also. Both will be forwarded through your emails. You need to check the emails that can be sent to the through email only. It will not be sent through WhatsApp group. Please try to remember. Okay. Akshita, Suma, Sudha, Vaishnavi, Prasad, Prasanna, Hani, Shamala, Balu, okay, Govind, Vamshi. Thank you, Varanana. Thank you. Today I don't have 27th. Sorry, 27th or 26th Sunday. Yes, 26th. Yes, Prasad, you are regular. Just Chintu also. Akshita, Cheti. Oh, JEE mains on September 1st to 6th. Very good. Oh, Neela Lakshmi Priya. Right. Okay, it's parents is better. At least 5 to 10 minutes let us spend with you. So let us start, no problem. Let us start. Let us start. Okay. #63 problem. Problem number 63. Problem number 63. There are 10 lamps. There are 10 lamps in a hall. There are 10 lamps in a hall. Each one of them can be switched on independently. Switched on independently. The number of ways in which the hall can be illuminated is: first option 2 raised to 10 minus 1, second option 2 raised to 9 minus 1, third one 2 raised to 10, fourth option 2 raised to 9. This is the question. Thank you. Right. Here see, there are 10 lamps in a hall. What is the condition? We have the condition that each one of them can be switched independently. There are actually 10 independent switches. So in order to actually eliminate it, they can be operated independently. So that means how a room can be eliminated means room should have the light. Room should have the light means even we can switch one switch or two switches or three switches or at least one switch. So that means actually here see, out of 10 lamps, so one lamp can be selected, or room can be lighted, illuminated, or even with the help of two lights, or with the help of three lights, and with the help of four lights, with the help of even dash 10 lights also. So this is nothing but actually this seems to be rather, we have the formula nc1 plus nc2 and so on ncn. This is nothing but 2 raised to minus 1, 2 raised to the power of n. So this equals to 2 to the power of 10 minus 1. That means first option is the right option. Even you can simplify also, no problem. Yes. Now 60. What is the problem number? Anybody? Sixty-fourth question. 64th question. For any integer n greater than or equal to 1, that means n is a positive number greater than 1, the number of positive divisors of n is denoted by d of n. D of n means the number of divisors. Then for a prime, that means prime number, for a prime p is a prime number, d of divisors of p to the power of 7 equals to, this is the question. First option 1, second option 2, third option 3, fourth option is P. So that means actually here see, for any integer n greater than or equal to 1, n may be 1, 2, 3, 4 like that. So n is a number. The number of positive divisors of n is denoted by d of n, this symbol, for prime p. Then d of p to the power of 7 you need to find out. So that means actually d of p to the power of 7 is equal to number of divisors of one prime number. It may be anything, 2 or 3 or 2 to the power of 7, 3 to the power of 7 or 5 to the power of 7. So here power you need to take it, 7. 7 plus 1 is equal to 8. Again this 8 can be written as 2 cube. So that means this bracket we evaluated. Now we need to evaluate this bracket now. That is what d of p power 7. Now instead of d of p power 7 you can write 2 cube. 2 is a prime. So d of 2 cube. D of 2 cube is equal to 3 plus 1 is 4. Again this can be written 2 square. Now we need to find out this d. So that's why now we need to write d of p to the power of 7 equals to d of this 2 square we need to write. So d of 2 square equals to, we can write 2 plus 1 which is 3. Answer is 3. That means third option is the right option. Third option is the right option. This is the solution. 65. 65. Right. 1 minute. I need to sit properly. Right. If n denotes the set of all positive integers and if f maps n to n, natural numbers to natural numbers, a function is defined by f of n is equal to the sum of positive divisors of n. So sum of all the positive divisors of n, that is given by f of n function. Then f of 2 to the power of k times 3, where k is a positive integer, is first option 2 raised to k plus 1 minus 1, second 2 times 2 raised to k plus 1 minus 1, third option 3 times 2 raised to k plus 1 minus 1, fourth option 4 raised to 2 power k plus 1 minus 1. All of you just read the question. Okay, Gopal, I'm sorry, taking rest. Okay. N denotes the set of all positive integers from n to n. Function is defined by f of n is equal to the sum of the positive divisors of n. The definition is given like this. Function n is defined by the sum of the positive divisors of n. Then we need to find out f of 2 power k times 3. That means 2 power k times 3 is actually, this is canonical form or product of the prime factors. That's okay, that's enough actually. We have shortcut formula. 65 question solution. Note down shortcut formula. Let n is equal to, for example, the number is written as canonical form p1 to the power of n1 times p2 to the power of n2, p3 to the power of n3 and dash dash so on, where p1, p2, p3 are primes that you remember. Next, them sum of divisors, sum of divisors sum of distinct positive divisors is given by the formula. See, this is P1. First P1 write down. What is the power N1? N1 plus 1 minus 1 upon P1 minus 1 times, we need to multiply, P2 to the power of n by 2 plus 1 minus 1 upon P2 minus 1 times P3 to the power of n3 plus 1 minus 1 upon P3 minus 1 into dash dash. Now let us come to the problem now. So now let us come to the problem now. Now we have f of what is given actually here, 2 to the power of k times 3 to the power of 1. That means P1 is equal to 2, P2 is equal to 3, N1 is equal to k, N2 is equal to 1. Substitute in this one. So we get this one, 2 to the power of k plus 1 minus 1 upon 2 minus 1 multiplied by, here 3 power 1 plus 1 minus 1 upon 3 minus 1. So now we need to simplify this one. So this equals to 2 power k plus 1 minus 1 upon 1 is 1 only. Here 3 square minus 1. 3 square minus 1 upon 2. This is 2 raised to k plus 1 minus 1 times 3 square is 9 minus 1, 8 into 4. So this is the answer. Which is the right option? This one. Which is the right option? So now fourth option is the right option. 66th question. 66th question. So let us move to the 66th question. 66th question. Okay. The number of three element subsets are formed from the elements of the set A equals to A1, A2, A3 and so on dash dash AN, which contain AN, which contain AN is first option NC3, second option N plus 1 C3, third option N minus 1 C2, fourth option 2 to the power of N. Sorry. Problem has not been completed. This is the question. Thank you, Sanjay. Hello, Revati. What do you want? Sheshurao. Okay. So this problem actually can be modified. So that means generally the problem solving strategies actually the problem can be restated to the equivalent problem. So we need to restate the equivalent problem. So what we need to restate this equivalent form means the number of ways of selecting 3 persons out of the n persons, which exactly an always includes, including exactly particular person an. That we need to find out. That's all. So that means the problem can be restated. Here the number of 3 element subsets formed from the elements of the set, this one, an elements, always it contains an elements. So that means actually here see 3 elements we need to select. Exactly an must contain. So you place an. Now we need how many? Just 2 only. Already an is actually got selected for 3 out of n. So now the remaining elements will be n minus 2 and remaining selections are to be made 2. So that means from n minus 2, 2 can be selected now. So that means actually see solution here. Total number of elements is equal to n of a, cardinality of a, that is n. Okay, so now exactly it must contain as every subset contain an, that means element an. So now number of elements, is equal to n minus 2. So now number of elements to be selected, 2. Therefore required number of ways is equal to n minus 2 C2. This is the answer. Sorry, 1 only, n minus 1, because only one selected. Sorry, n minus 1 C2. n minus 1, this is n minus 1. n minus 1 C2 is the answer. Yes, exactly correct. N minus 1, not n minus 2, because only exactly definitely in 3 element subset an should contain. This is the plan. So now executed plan. 67. If 20% of 3 elements of subsets, formed from the elements of A1, A2, A3 and so on an are three elements subsets with an element A1 with an element A1, then n equals to first option 15, second option 16, third 17, fourth 18. First read the question. So you need to try to understand the problem. If you understand the problem easily, we can crack the problem. There is no problem for us. That means we need to divide it. 20% of the three elements of the subsets. That means three element subsets can be made using n elements is nc3, but 20% of them, 20% of nc3 are means equal to three element subset which contains always a1, means already a1 being selected, so n minus 1 c2. That means 20% of nc3 is equal to n minus 1 c2. That is the problem. We need to solve it now. So let us solve it now. Solution is what is given actually here. 20% of number of three element subsets. Now it will be cleared, equal to number of three element subsets which contain always a1. A1 need to be included. So that means this can be done like this. Now we need to make a new problem. What is the problem? 20% of here nc3 equals to, so now remaining is n minus 1, 2 need to be selected, n minus 2. 20% means 20 by 100. This is equivalent to the fraction 1 by 5th. So that means 1 by 5th of nc3 equal to n minus 1 c2. It's a combination problem. You need to solve that. Okay, you need to solve this one now. So let us solve it now. 1 by 5 nc3 equal to n minus 1 c2. nc3 means n times n minus 1 times n minus 2. 3 factorial is 6 equal to 5 times n minus 1 into n minus 2 upon 2 factorial 2. 2 1 ja, 2 3 ja. Here very interesting, n minus 1 into n minus 2, n minus 1 into n minus 2. These two factors will be cancelled. N upon 3 is equal to 5. Therefore, n equals to 15. There were 15 elements in the set. This answer. Yes. So 15. All of you got it? I hope you will understand. Thank you. Thank you. Now 68. Problem number 68. Problem number 68. the number of ways that 30 mangoes can be distributed among 5 boys is first option 34C4, second 35C4, third option 36C4, fourth option 33C4. So this is very important problem. It will be useful for even JEE mains also. Okay, Bhumika. Thank you for your concern. The number of ways that 30 mangoes can be distributed among 5 boys. Among 5 boys we need to distribute. So that means actually here see how can it be done means suppose first person, second person, third person and fourth person and fifth person. There are 5 persons. Among 5 persons 30 mangoes are to be distributed. Are to be distributed means the first person may not get either 0, that means 0 to 30, second person also 0 to 30. This also total it must be the number of mangoes with 5 persons must be equal to 30. So that means this problem can be rewritten. Restatement. What is the restatement means? This can be done like this. x1 plus x2 plus x3 plus x4 plus x5 is equal to 30. x1 plus x2 plus x3 plus x4 plus x5 is equal to 30 means it is a linear equation in 5 variables. It's a linear equation in 5 variable means x1 value, x2 value, x3 value, x4 value, x5 value we shall get it. So that is nothing but actually the number of ways that can be 30 mangoes can be distributed among 5 boys. That means the problem need to be restated. How to restate that I will right now. First I will give the shortcut, then I go for the restatement. Shortcut. Always remember all of you this shortcut. What is the shortcut means? The number of non-negative integral solutions of x1 plus x2 plus x3 plus so on xr, there are r variables, is equal to n is given by n plus r minus 1 c r minus 1. This you need to remember. This is the formula. So all of you remember this formula. This is very important formula. So now I change the problem like this. You see the number of non-negative integral solutions of x1 plus x2 plus x3 plus x4 plus x5 equals to 30. Now the problem has been restated. So using this we need to find out now. So now here n equal to 30, this is the r value, r equal to 5. Number of ways is equal to, substituting in this one, 30 plus 5 minus 1 c 5 minus 1. So this equals to 34C4. So now, okay Sumant, option 1. So now these kind of equations are known as Diophantine equations. Diophantine equations. Whenever, for example, two variables are there, we need to get unique solution to independent linear equations. For example, here we have 5 variables, means we need 5 independent equations to get exact unique values for x1, x2, x3, x4, x5. But only single equation is given, we need to apply the Diophantine equations. So the Diophantine equations are very important for your future learning. That means if you opt any BTech, CSE or IT, or you go for coding, Python courses, other courses, this Diophantine equation solving is very important criteria. You need to concentrate number theory. Number theory is in the part of cryptology. So that I need to give some suggestion to you also. This chapter is very important for not only for Eamcet, particularly all of you remember, please remember, it is very important for your future learning also. 69. The number of ways of selecting the number of ways of selecting 10 balls out of unlimited number of white, red, green and blue balls is first option 236, second option 256, third option is 276, fourth option is 286. See, there are unlimited number of white balls, red balls, green balls and blue balls. We do not know. Let the number of white balls may be x1, red balls may be x2, green balls is x3, blue balls is x4. x1 plus x2 plus x3 plus x4 is equal to 10. That means now we need to find out the number of non-negative integral solutions of the equation x1 plus x2 plus x3 plus x4 equals to 10. That's only. You need to solve like that. So now the problem can be restated. Solution. Restatement. The number of non-negative integral solutions of x1 white balls, x2 red, x3 green, x4 must be equal to 10 only. 10. Now we need to find out is. So that is the formula. What is the formula we have? N plus R minus 1 C R minus 1, which is equal to, here N equals to 10, R value equal to 4 variables, R is equal to 4. Substituting 10 plus 4 minus 1 C 4 minus 1. 4 minus yes, 4 minus 1. So 13C3. Let us find out 13C3. 13C3. Yes, wonderful, wonderful, everybody. So 13 into 12 into 11 upon 3 factorial means 6. 6 1 ja 6 2 ja. So now 13 into 66 into 1 1. That means 6. 6. Sorry, 1 minute, 1 minute. I did mistake. I did mistake. Calculation mistake. Okay, 26 times 11. That means 6. 2 plus 6 2 is 8. 286. That means fourth option is the right option. This also important problem. 70. 70. If n is a natural number, then the number of non-negative integral solutions of x plus y plus z equals to n is first option is n times n minus 1 upon 2. Second, n plus 1 times n plus 2 upon 2. Third, n plus 1 times n upon 2. Fourth, n times n minus 1 upon 3. This is direct question. Yes, direct question. N is a natural number, then the number of non-negative integral solutions of x plus y plus z is equal to n. Here, that means actually solution we have required number of solutions is equal to n plus r minus 1 c r minus 1. Here r means 3 because 3 variables. So n plus 3 minus 1 c 3 minus 1, that is n plus 2 c2. That we can write n plus 2 times n plus 2 minus 1 is n plus 1 upon 2. So that means second option is the right option. Second option is the right option. 71. 71. The number of positive integral solutions of ABC is equal to 30. Product of the three numbers is 30. Is first option 30, second option 27, third option 8, fourth option 9. The number of positive integral solutions of ABC is equal to 30. Not A plus B plus C is equal to 30. A plus B plus C is equal to 30 means we have the formula. But for A into B into C is equal to, we don't have the formula. We need to see the combinations. Different combinations for A, B, C. That we need to write it now. So let us write now. Say A, B, C. Okay. So we need to select the numbers such that whose product is 30. That means we can select like this. 1, 1, 30. So 1 into 1 into 30, 30 we get it now. So next 1, 2, 15. This is also 30. Right now. Next one more combination also we can write 2, 3, 5. 2, 3, 5. 30. Next combination is 1, 5, 6. So next combination is 1, 10, 3. Any more? Any more? You try it now. You try it any more. So that means how many number of ways you get chances you will get it now. See, this is one chance, second way, third way, fourth way. This is fifth way. 5 ways. But actually what happens means you may have one doubt. Why should be A is equal to 1? Why should be B is equal to 1? They can be rearranged. They can be rearranged means this we get 3 factorial combinations. Here also, but here 1 is repeated. 3 factorial by 2 factorial. But this is 3 factorial. Different. This is 3 factorial. This is 3 factorial. This can be arranged 3 factorial. That means now solution required number of ways is equal to 3 factorial by 2 factorial plus this 3 factorial is added for 4 times. 4 into 3 factorial. 3 factorial is 6 upon 2 factorial is 2. 4 into 6. 2 1 ja, 2 3 ja. 3 plus 24. That means 27 number of solutions we shall get it. Second option or shortcut. What is the shortcut means? What is the shortcut means? A, B, C should be equal to 30. This 30 we can write 2 5 ja 10, 10 3 ja. Product of the prime numbers. 2 is a prime number, 5 is a prime number, 3 is a prime number. So this can be 2 can be assigned. 2 can be assigned 3 ways for A, for B, for C. 5 can be assigned to A, B, C 3 ways. 3 can be assigned 3 ways. 3 into 3 into 3. So number of ways is equal to 3 into 3 into 3. So which is equal to 27. So second method also we can do it. Second method, you check it second method now. So 30 we have written 2 into 5 into 3. A can be 2, B can be 2, C can be 2. 3 ways. A can be 5, B can be 5, C can be 5. 3 ways. C can be 3, A can be 3, B can be 3, C can be 3. That means 2 is assigned to A for 3 ways. Sorry, 2 can be assigned to these 3 values 3 ways. 5 can be assigned to 3 ways. 3 can be assigned 3 ways. That is 27. Yes. So this is very easy second method, because sometimes you may be asked like this also: x1 into x2 into x3 into x4 into 5 is equal to something. Find number of positive integral solutions. You may be asked such question also in the examination. But this is the concept I have given. Seventy-two. The position vector of a point P is r bar is equal to xi I cap plus yj cap zk cap, where x comma y comma z belongs to the natural numbers. They are the set of natural numbers. And A is equal to, that means A bar equals to I cap plus j cap plus k cap. If r dot A is equal to 10, then the number of positions of P is first option 36, second option 72, third option 66, fourth option 48. This is the connection between vectors and combination chapter. This is called connection problem. Position vector of a point P is equal to r bar given, where x, y, z are natural numbers. That means non-integral values. Sorry, not non-integral, positive values, positive integral values. A equals to I plus j plus k, r dot A is equal to 10. So first let us find out r dot A. So let us find out first r dot A. The problem can be restated. R dot A equals to 10 given. That means dot product between these two vectors. Dot product between these two vectors means I cap I is 1, x plus y plus z is equal to 10. Now the problem can be restated. So that means number of actually here what we need to write means positive integral solutions. Because they should not be 0. Integral solutions of equation x plus y plus z is equal to 10 of Diophantine equation is given by the shortcut. I will give the shortcut, don't worry. That is n minus 1 c r minus 1. See here, this is n is equal to 10. Number of variables r is equal to 3. Now substituting 10 minus 1 c 3 minus 1, 9c2. 9c2 equals to 9 times 8 upon 2. So 2 1 ja 2 4 ja 2 1 ja 2 4 ja. I am very poor in calculations. Please try to understand. You need to rectify yourself. Huh? Okay, 9 times 8 upon 2 times 1. 2 4 ja. Okay, 36. So that means there are 36 position vectors will exist in the plane or space it may be. So first option is the right option. So I said n plus r minus 1 cr minus 1 is for non-negative. Non-negative means there may be actually 0 may be included. But here x should not be 0, y should not be 0, z should not be 0. In the previous cases maybe 0 may be included solution. So that's the difference you need to find. When should we use n minus 1 cr minus 1? See, whenever positive integral solutions. Non-negative means the formula is this one. N plus r minus 1 cr minus 1. This is non-negative. Non-negative. This is the keyword. This is the keyword. Here this is the keyword. This is the keyword. Positive integral solutions. '73. The number of ways, 9 things, the number of ways 9 things can be divided into three equal groups. Three equal groups is first option 9 factorial upon 3 factorial, second 9 factorial upon 3 factorial to the power of 4, third 9 factorial upon 3 factorial whole cube, fourth 9c3. So one must be tempted, sir, when one is yes, always taken, but always 0 is not included, that means. So now the number of ways 9 things can be divided into 3 equal groups is 3 equal groups is, one must be righted. Fourth option, no, fourth option is wrong. 3 equal groups means 3 things each we shall get it. So that means we need to select 9c3, next 6c3, next 3c3 ways. So that means actually you get like this now. Directly I will write the answer. So number of ways is equal to, so you need not remember any formula, directly you can proceed with the problem. So 9 factorial write down upon in 3 groups, each group contain 3 elements, that is 3 factorial times 3 factorial times 3 factorial. Because they are not unequal, equal means they are seem to be same, so that we need to write divide by 3 factorial also. That means we get 9 factorial by 3 factorial all to the power of 4. So second option is the right option. So now the same question may be given to get you confusion. The number of ways of 9 things can be divided equally among 3 persons. That's a different. That means first we need to do the number of ways and multiplied by the among 3 persons means that can be distributed 3 factorial ways. So that we need to multiply. Okay, 74. The number of ways nine things be divided equally among three persons is first option 9p3 times 6p3 times 3p3. Second, 9 factorial upon 3 factorial whole to the power of 4. Third one, 9 factorial upon 3 factorial whole cube. Fourth option, 9 factorial upon 3 factorial. Yes. So that means first we need to select the number of ways of 9 things can be divided into 3 equal groups first. After that we need to distribute to 3 persons. First, so solution, required number of ways is equal to first selection making the 3 equal groups, that is 9 factorial by 3 factorial times 3 factorial because 3 factorial into distributed to the 3 persons 3 factorial gets cancelled. We have 9 factorial upon 3 factorial whole cube. This is the answer. Right. Similarly, for example, playing cards are there, pack of cards, that is consisting of 52 cards. How many ways actually we can equally divide into the 4 parts, 4 shoots. 4 shoots means 52 factorial by each shoot 13 factorial into 13 factorial. But we need to write 4 factorial also because 4 is there. So let us do the problem, that is 75th problem. 75th problem. The number of ways in which 52 cards be formed into 4 groups. That means equally divided. 4 groups of 13 cards each. 13 cards each. That is called shoot. Each shoot. First option 52 factorial upon 13 factorial to the power of 4 into 4 factorial. Second is 52 factorial upon 13 factorial whole to the power of 5. Third one, 52 factorial upon 32 factorial. Fourth one is 52C13. Okay, that means actually here see, we need to divide the 52 cards, 52 pack of cards. How many shoots we have? 4 shoots. 4 shoots. Actually this is this card. Okay. Next is like this, black and red colors. Here equally means it has 13 cards, 13 cards, 13 cards and 13 cards. That means 52 contains 32 spade, 32 club, 32 heart, 32 diamond cards. Understood now? So that means actually your solution number of ways is equal to total cards is 52, 52 factorial upon, we can write 13 factorial into 13 factorial into 13 factorial into 13 factorial. But how many groups we have? 4 groups. So we can write into 4 groups. That's all. So 52 factorial upon 13 factorial raised to 4 into 4 factorial. We check. That means first option. Same thing, if it is distributed among the 4 persons means it is multiplied by 4 factorial. 4 factorial cancel. 76th problem. This is the last problem of the permutations and combinations. We shall conclude the session. That means most of the models have been covered on Eamcet level. Don't worry, on the Eamcet level if you go through all this one you can solve the problems. On IDJE section then I discuss more than level 3 level 4 problems later. The number of ways 52 cards be divided among 4 players so that each may have 13 each. First, how many number of ways the groups can be formed of 13 each? Then we need to distribute 4 persons. That can be arranged 4 factorial ways. That's all. So that means solution, first option write down 52 factorial upon 13 factorial all to the power of 4. Second one is 52 factorial upon 13 factorial all to the power of 4 factorial. Third option is 52 factorial upon 13 factorial all to the power of 5. Fourth option 52 P13. First this is to be done, after that multiply by 4 factorial. So that means actually here see solution required number of ways equal to first 52 cards dividing into the groups, dividing the equally groups, 3 equal groups. That means 4 equal groups means 13 each. Already see, you might have experienced in this problem 13 spades, 13 club, 13 diamond, 13. So this will be, you will get 52 factorial by 13 factorial into 4 times 4. So that means we can write 52 factorial upon 13 factorial power 4 times 4 factorial. But it is here key point is among 4 persons we need to divide. Among 4 persons. So that means that can be done 4 factorial ways. 4 factorial cancel. We have 52 factorial by 13 factorial raised to 4. That means first option is the right option. So end. Chapter has been completed. Thank you. I try my level best to complete the permutations and combinations. Actually, most of the viewers requested me to complete the permutations and combinations in the initial stages itself only. But the permutations and combinations is very easy chapter. So at the end I started. First I started difficult topics, then I completed the among persons means actually how many you will just divide. 52 cannot be divided equally. So that's why it's not possible. Generally 4 persons. Okay, right. Equally cannot be done. That means 52 C3 Next 49 53 not CT 52 13 39 C13. Next is 26 C13, that is Narla. Okay, for 3 persons actually you asked the question 52 C3 C13 for one. Next 52 minus 13 is 49 C13. This is 36 C13 multiplied by 3 factorial. This you remember, Narla. Okay, bye. One more thing, all of you need to wait. Nagamani, Sai Pranit, give this feedback in the comment section. That's a better thing. Okay, right. Thank you. Bye bye. Okay. So I will explain later. Any doubts are there? I will. Okay. Thank you. Thank you. Thank you. Thank you. Thank you. Okay. So today by 7:30 I have the class because I need to take rest up to 4:30. So better you give me the time, leisure time. So better by 4 evening 7:30 we shall continue this complex numbers for Ecet students as well as Mset students. Thank you. Bye. Have a nice day.